Welcome to homework.
Okay, let's take a look at this problem. We've got the following. Molecule. And we're told that after reacting with methoxide, let's just call it base, we can get two possible elimination products. Oh yeah, and this is an ethyl group, CH2CH3. And we need to know what those two products are, first and foremost. Well, why do we get two elimination products? Consider or recall that for E2 reactions, it's necessary to have our leaving group in an anti-periplanar coordination, or anti-periplanar to our leaving group, our leaving group needs to be anti-periplanar to our proton, which will be deprotonated, right? The base comes in, and this configuration needs to be respected or maintained, right? How that translates to derivatives of cyclohexane is that if we look at them in the chair conformation, if we look at the neighboring carbons, like here is the carbon that has our leaving group, and we look at this equatorial bond to bromine, we see that bromine is, beneath the ring, or it's beneath the other substituent. Well, to be anti-periplanar to something else, it's got to be on an adjacent carbon that is above the ring, or the upper of the two substituents. So it could be this proton or this proton. Right? Either of those protons could, after a chair flip, give us a product or give us a conformation in which bromine is anti-periplanar to one of these neighboring hydrogens. Right? And there are two options. So we can either get a double bond here, or we can get a double bond here. Right, so one of the products, if we were to draw this in top down, would be a double bond next to the ethyl group, whereas the other would be one carbon away from the ethyl group. So those are the two different products we can get. Now, when we consider instead this stereoisomer, let me draw a better chair than that. Okay. We'll notice that this bromine could be arranged anti-periplanar to this hydrogen, but unlike before, this bromine is on the opposite side of the ring as the ethyl and not the hydrogen as it was before, right? So it can no longer be put into a configuration in which the bromine and the neighboring hydrogen would be anti-periplanar, right? If we did the ring flip on this molecule, and this is our bromine now, we can be anti-periplanar to that hydrogen, but we can't be anti-periplanar to this hydrogen. We can only be anti-periplanar to the ethyl group, which will not give us the elimination product we need. So therefore, our only possible product from the second substrate is one in which the double bond does not neighbor the ethyl group. Account for the difference in reaction products between the two stereoisomers. Well, I think I just did that, right? I mean, we just stepped through why it is that we can get two. I guess just for the final bit of clarity here, I'll draw the chair flip of the original product, or of the original isomer, so you can see how it is that the periplanar anti-periplanarness works out. So now our bromine is the lower of these two. Okay, and then here we've got the bromine was always lower too. What's different is here, where the hydrogen is the higher of the two. Right, so now our possible anti-periplanar configurations are with the bromine and this hydrogen here, and the bromine and this hydrogen here. All right, we've got two possible paths to an E2 reaction, whereas in this case, there's only one that's possible.